Hi there, welcome to the Vectors exam questions video, just looking at different exam questions. So starting off with a nice easy one here. Firstly, looking at the components of vector AB, we know that to find the components of the vector AB, we're going to do the vector B subtract the vector A. Okay, so the vector B here is converting this coordinate into a position vector, minus 1, 3, 2. Subtract the position vector A, which is minus 3, 2, 4. Okay, so -1 subtract -3 is 2, 3 subtract 2 is 1, and 2 subtract 4 is -2. Okay, and part B, the length of AB, or another word for length is your magnitude. We know that AB is 2, 1 minus 2, so the magnitude is going to be 2 squared plus 1 squared add -2 squared. So 4, 4, and 1 is √9, so the magnitude of AB is 3. Okay, now to look at the marking. Okay, the first mark is for getting the vector here, just 1 mark for getting the answer. 1 mark in part B for knowing how to find the magnitude, and then a second mark for completing that calculation. Okay, question 2 here, the vectors P, Q, and R defined as follows. Okay, so using the basis vectors I, j, and k, find 2p minus q plus r in terms of I, j, and k. So personally, I prefer working with these vectors in columns. So 2p really means 2 times 3 minus 3, 2. Take away q, that really means 4 minus 1, 1. And then add r really means r is 4 minus 2, 3. Now that comes from the coefficient of I, the coefficient of j, and the coefficient of k in each case. Okay, so putting them together, 2 3s are 6, take away 4 is 2, add 4 is still going to be 6. 2 times -3 is -6, take away -1 is -5, add -2 is -7, and then 2 2s are 4, take away 1 is 3, add 3 is 6. Okay, so there's your column vector. It is asking to put it in terms of I, j, and k though, so that's equal to 6 i's minus 7 j's plus 6 k's. Okay, and then B, very similar again, 2 similar questions to start. We're now finding the magnitude. So that magnitude of 2p minus q plus r is equal to the square root of 6 squared plus -7 squared plus 6 squared. Okay, and just calculating that, you get 72 plus 49, so that is 121. Okay, so it was √121, which is just going to be 11. Same marking as last time. Okay, first mark for getting the vector written in those terms. Second mark for notifying the magnitude, and the third mark just for calculating that magnitude. Finally, okay, now the vector AI bj plus k is perpendicular to both the vectors I subtract j plus k and -2 plus j plus k. Find the values of A and B. Okay, so the key point here, the one that we need to go to as soon as we start talking about perpendicular vectors, either proving or using, is that for perpendicular vectors, the dot product is equal to 0. Okay, 2 ways to find the dot product. One from the magnitudes in your cosine, but the other, which will be preferable here, is if you know the components, then you can just multiply them all the i's, all the j's, and all the k's, and then add them together. So here we have a vector that's perpendicular to 2 different vectors. So firstly, we're going to do vector 1 and vector 2. They're perpendicular to each other, so we know the dot product there is equal to 0. Okay, so the dot product there is A, B, 1 dot 1 minus 1, 1. We know that has to equal 0. So that's going to be A subtract B plus 1 is equal to 0. Okay, A times 1 is A, B times -1 is minus B, and 1 times 1 is 1. The same idea here, vectors 1 and 3 are also perpendicular, because we know this is perpendicular to them both. So same again, A, B, 1 dot minus 2, 1, 1 is equal to 0. So that means minus 2a plus b plus 1 is equal to 0. So there's your two equations that you need in order to solve these for a and b simultaneously. Okay, there's several different ways you can do that. I'm going to do it the classic Nat 5 way. Okay, so then these are different, so we're going to add them together. So it's minus a is equal to minus 2, so a is equal to 2, and then subbing back in, let's put it back into the top one, 2 subtract b is equal to negative 1, so negative b is equal to negative 3, so b is 3. So marking 1 for each equation here, and then 1 for solving the simultaneous equations. Okay, let's move on. Question 4. Show that the points LM and N are collinear partly, and then find the ration. And that should say ratio in which N divides LM. So for part A, collinearity is the same for straight line as in vectors. First, you want to show that all along the line, so two different sections are parallel, and because within those two sections you have to be using a point in common, that is a fact that proves that they're collinear. Now in straight line, they're parallel because you prove the gradients are the same. Here, they're parallel because you prove one vector is a multiple of the other vector. So let's look at two of the vectors. Now it doesn't matter what two you choose. LM is equal to M subtract L. So M is the position vector 7 minus 2 minus 1 directly from the coordinate, and L is a position vector minus 5, 6 minus 5, again directly from the coordinate. So 7 take away negative 5 is 12, minus 2 subtract 6 is 8, and minus 1 subtract negative 5 is 4. Okay, now I'm just going to take out the common factor here just because that can always prove helpful. There's a common factor of 4. So that's 4, and then 3 minus 2, 1. Now let's use M and N. Okay, Mn and N subtract M, which is the first vector N, which is 10 minus 4, 0. Subtract M, which is 7 minus 2, minus 1. Okay, and that gives you 3 minus 2, 1. So you can see there, with that common factor out, LM is just a multiple of the vector Mn. Now because they're multiples, you essentially have the same vector in the same direction of different lengths. Okay, which means they have to be parallel. Now, you've done your work, you just need to make your statement, and your statement needs to be good. Okay, firstly, you need to state the ratio. So LM is 4 lots of Mn. Okay, to get this vector here, we do 4 times that vector. Therefore, or so, let's use the fancy therefore with 3 dots, LM, okay, LM is parallel to Mn. Okay, so that's your first key point. We're doing this work to prove that they are parallel, and then because that M is a point in common, that means that they have to be collinear. L, M, and N are collinear. That has to be your explanation. Okay, one is a multiple of the other, and I found that out, and I found that out because now I know that that's parallel to that, and because M is at a common point, these parallel vectors actually have to be in the same straight line. One has to be connected to the other. Okay, that's how you prove collinearity. Now part B is just one mark. Find the ratio in which M divides Ln. Now for this, I just like to do it a nice, easy, straightforward way. Okay, so Lm and Mn from the distance from L to M and the distance from M to N. Looking at it in terms of the x coordinates first of all. Okay, so the difference between the x coordinates from L to M from -5 to 7 is 12. From m to n, it's 7 to 10, which is 3. Okay, for the y coordinate, again, from 6 to -2, you're going down 8. And from -2 to -4, you're going down 2. Okay, and z, from -5 to -4, you're going 4. From -1 to 0, you're going 1. Now, all of these ratios simplify to 4 to 1. And it's something that you could get from your work over here. But if a question is standalone or you want to double check, you can use your x, y, and z coordinates just to check that you do that. So your ratio is 4 to 1. Okay, the same thing you can come out of here as well. Okay, now marking. Okay, in A, a lot of marks for collinearity question. Okay, you're going to get 1 for each vector, 1 for the ratio, and then 1 for your statement. Okay, now normally they would be 3 marks. Okay, 1 for each vector and then 1 for your statement at the end. Okay, and you're going to get additional mark there for part B for saying the correct ratio. Okay, that is a very generally marked question, so I wouldn't expect that all the time, but absolutely that's what it would be there. Okay, question 5, where the point Q divides a line joining P and R in the ratio 2 to 1. Find the coordinates of Q. Okay, these ones here, let's start with a diagram. Nice, easy thing to do. So we've got P, Q, and R, and the ratio is 2 to 1. Okay, now there's 2 or 3 different methods for answering these questions. Okay, section formula is 1. Guys that are in my class will know that I despise that method. I hate it. What I prefer doing is just looking at that, making a simple statement, and then using maths, using vectors, using the laws we know to work with it, to solve it. So there's not just going in remembering a big scary formula, but you're going in with a level of understanding, and you can attack this question regardless of the situation. Okay, now the statement I need you to make, or the statement you need to make in order to access this question is, right, if we go from P to Q, what fraction of the whole line do we actually cover? Now in there, you're going there to there is 2 bits, and you've got 1 bit up here as well. So overall, P to Q is 2/3 of that whole line, P to R. Now, if you can make that statement, that becomes a nice, easy thing to work with. 2/3 of P to R, we can do. That's 2/3 of, well, R minus P. We can calculate that. That's something we can do nice and easy. So it's 2/3 R is 5/2 minus 3. Take away P, which is -1, -1, 0. So really what I'm doing is 2/3 of, well, 6, 3 minus 3, which means 2/3 of that. 1/3 is 2, 2/3 is 4, 2 minus 2. So we know just from a straightforward vector calculation, not a Velcro calculation, that's something different, that PQ is equal to 4, 2 minus 2. Now, we're not really interested in PQ. We just want to know the coordinate Q, which we know is exactly the same as the vector Q, which you get from unraveling that PQ into Q minus P. So if I want to find Q, I just need to add P to both sides, isolate the Q. So I'm going to add P, which is -1, -1, 0. So Q is 3, 1, -2. I'm asked for coordinates. Don't do all the work and then forget to put it as coordinates. Your coordinate of Q is now 3, 1, -2. Okay, as I said before, lots of different ways to do that, probably 3 to be honest, at least. But I like that way because it's just using stuff that you can do and do comfortably and working away with that. Okay, so here 1 mark for making your initial statement, 1 mark for getting your 4, 2 minus 2, and then your 3rd mark for calculating your coordinate. Okay, number 6, find the value of k for which the vectors are perpendicular. Okay, we know for perpendicular vectors, the first thing that should be come to our head is that a dot b is equal to 0. Okay, so the dot product between these two vectors, because they are perpendicular, has to be equal to 0. So 1, 2, minus 1, dot minus 4, 3, k minus 1 has to equal 0. So 1 times minus 4 is just negative 4. Add 2 times 3, which is 6. Add minus 1 times k minus 1 is equal to 0. So minus 4 add 6 is 2. Negative 1 times k is negative k. And negative 1 times negative 1 plus 1 equals 0. Add k to both sides. You're going to be left with 2 add 1 is 3 is equal to k. Okay, now it all comes from that statement, and you need to have a reflex reaction. As soon as you are talking about negative vectors, or sorry, rubbish, as soon as you're talking about perpendicular vectors, you should be looking for the dot product and making it equal to 0. Okay, so 1 mark for making the dot product equal 0, 1 mark for calculating that dot product correctly, and then the third mark for solving. Okay, we're flying. Question 7. Okay, now that's a question that a lot of kids that I've worked with struggle with at first, but as soon as they see how to do it, it's something that they jump right into and find really easy. Okay, now here you have information about 3 vectors, v to a to b, and a to d. K divides this side in the ratio 1 to 3, and you want to find the vector vk in component form. That means you have to start at v and end at k to get that vector. Now, ideally, what we'd want is we just want the straight vector. If we know that as a squish, we just write it down. But we don't have that. But what we have to do is start at v, use vectors we know, and work our way around the shape until we get to k. So what we're going to do to get vk, well, I need to start at v, and I need to come down to the bottom there. The only one I have that does that is va. So I'm going to start at v, and I'm going to come down va and end up here. So my first step in my journey is to go v to a. I want to get over here to k. So the next thing I'm going to do is come across from a to b. I'm going to add on a to b. The last thing I want to do is go from b to k. That's the last step I need to make. But I don't know what that vector is. I do know that it's a quarter, because it's 1 to 3, of the whole thing, which is b to c. Okay, but b to c I still don't know. Look at the ones here. I don't know what that is. But I do know that b to c is exactly the same as a to b. So that's really a quarter of AD. So VA plus AB plus a quarter of AD will get you the vector VK. And from there, it's just a case of doing your sums. VA is minus 7, minus 13, minus 11. Add AB, which is 6, 6, negative 6. Add a quarter of AD, which is 8, minus 4, 4. Okay, you just do your sum. Minus 6 add 6 is negative 1, add a quarter of 8, adding 2 is 1. Minus 13 add 6 is negative 7, add minus 1 is negative 8. Minus 11 add negative 6 is minus 17, add 1 is minus 16. So that is your vector vk. Okay, now these questions are difficult to access if you can't get that starting point. And it's all about is making it as easy as possible to get that. Okay, so the first one is known that you're going to be using a quarter of AD essentially, although you may be getting marked for some of this work up here. The second mark is for setting up the full vector sum, so using VA plus AB plus a quarter of that, and the third mark is calculating that correctly. Okay, so this one's starting to look at a bit more complicated vector questions. Okay, 7 markers, a big vector question that we want to come up. Okay, part 1 here, the point A has coordinates 0, 9, 8, and C has coordinates 17, 0, 8. Write down the coordinates B. Okay, so we want that coordinate there. Now, the key word here is the cuboid measuring these dimensions placed centrally on top of another cuboid. Okay, so the thing is centrally, it's not askew, it's bang in the middle. So to get to that point B, when you're going along the x-axis, you know this distance here is 17 for that bigger cuboid. And on top, that cuboid there is 11. So going in this direction, in the x direction, you have a spare 6. And because that cuboid is central, that really means there's 3 on each side. Okay, 3 here and 3 here. So the x coordinate across the x-axis has to be 3. Similarly, on the y-axis, 9 going back on the big one, 5 going back in the wee one, means there's 4 spare. And because it's central, 2 on each side. So the 2 for B is going to be 2 back along the y-axis. Okay, and then finally, the z-axis is just going to be the combined height of both of those, which is 15. Okay, so there's part A. Now calculate the size of angle ABC. So that's A to B to C. It's this angle here that you're looking to calculate. Now for vectors, we know from our formula sheet, if we're looking at vectors and we want to calculate an angle, we're going to be using this formula that we arranged. Okay, for cos theta. Now, the important thing here is to get the correct vectors. You know that we have to use the vectors pointing away from the angle. So what we're really going to do is not A and B, it's BA dot BC all over the magnitudes. Okay, because that's what you'll divide by to isolate the cos theta. Okay, and there, that's the work you have to do now. Okay, so BA dot BC, well, first we need to know what BA is and what BC is. I'm going to do all my work down here and then I'll come back. So BA is A minus B is equal, well, we now know that A is, it tells the point there 0.98. B was the one that we calculated, so that was 3, 2, 15. So that gives us negative 3, 7, and negative 7. Okay, so there's BA. BC, exactly the same process, C minus B is equal to this time 1708. Subtract my B, which is 3, 2, 15. That's 14, negative 2, negative 7 again. Okay, so there's my two vectors. Now I need my dot product. So BA dot BC is going to be minus 3 times 14, add 7 times minus 2, add minus 7 times minus 7. Okay, so that's the sum I'm doing. That looks a bit messy now. Okay, just calculate that. Which gives you negative 7. Okay, we now need magnitudes as well. Okay, so the magnitude of BA is the square root of minus 3 squared, add 7 squared, add negative 7 squared, which is root 107. 49 add 49 add 9, so root 107. And then the same thing for BC. Magnitude of BC is going to be 14 squared, add negative 2 squared, add negative 7 squared, which is root 249. Okay, so there's all your work. This is what you're using. We had vectors now, which meant we could get a dot product and we can get both magnitudes, which means cos theta is going to be negative 7 over root 107 times root 249. Okay, which means theta is inverse cos of that fraction. Minus 7 over root 107 root 249. Okay, and when you type that in, it gives you an answer. Give me a sec till I get it. Okay, it gives you 92.5 degrees. Okay, now marking what's going on here. Okay, the first mark in part A is just for getting that coordinate correct. The second mark, or the 6 marks here, the first mark will be for using the correct formula. Okay, with, and this can vary depending on the SQ's marking scheme, but with the correct vectors highlighted. Okay, a mark for each vector, a mark for the dot product, a mark for both magnitudes, and then a mark for working your way towards the angle. Okay, now that's quite a standard question. The context varies, but all about finding angles, using the dot product, using your magnitudes, very common question, and it's something that you should get used to. And even if you're making mistakes or you make a daft mistake, you can still pick up most of the marks there relatively straightforwardly. Okay, next one. Okay, bit involved. Lots of things going on, but it's again, it ends up being a similar question. You can see here we're calculating an angle. Okay, there's a lot of kind of context to this one, but that's fine. Okay, we've got a coordinate axis, blah, 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 a scale of 1 unit to 2 kilometers. Okay, and imagine that'll be important, 1 unit to 2 kilometers, and then position of these 4 things. So this is the origin, and then we've got coordinates. Find the distance from the bridge of the ship to the reflector on the aircraft. So the bridge to the reflector, we're trying to find that distance. Okay, so part A. Okay, part A here, we're looking for the distance, and we know that our distance would be the magnitude, the size of that line. Okay, so firstly, we need the vector. We need that vector B to R. Okay, which is going to be R subtract B, which is going to be 7 minus 4, 7.5, take away 5, 5 minus 0.5, which is 2 minus 9, 8. Okay, the magnitude of BR is equal to root 2 squared add negative 9 squared add 8 squared. Okay, which is root 146. Okay, now that's your magnitude of the vector using those coordinates, but because it's 1 unit to 2 kilometers, the distance is actually going to be 2 root 146. And looking back at my answers for the guys that are using them, I realised that I actually didn't notice that when I was doing. And I also can't read my own writing, it's 149, that's ridiculous. Apologies. See, that's been told you my secret now that I'm using my answers here. I know what I'm doing. I'm looking at the next question. Okay, so B, 3 minutes earlier, the aircraft was at point M. Find the speed of the aircraft in kilometers per hour. Okay, so here it's just a speed distance time sum. If we know the distance between where it was and where it is now, we know the time. It's 3 minutes, and we can convert that into, or we can use speed distance time to find the speed. Okay, so again, very kind of similar work here. We want to know the length of that line, or the distance it's travelled between M and R. Okay, so it's going to be 7 minus 4, 7.5, subtract M, which is this new point, minus 2, 4, 8.5. So 9 minus 8, and then minus 1. Okay, the magnitude then of MR is equal to the square root of 9 squared plus minus 8 squared minus plus minus 1 squared, which gives you root 146. Now, if we want to know the speed, we need to know the distance divided by time. Okay, the distance is going to be 2 lots of 146. And then the time, now what I would do here is, because we're talking about it in per hour, you're looking at 3 minutes. So that actually, well, it was 23, so you're dividing it by 1/20th. Just so you're looking at it in kilometers per hour. Okay, so what that really means is 40 root 146. Okay, so that's your part B. A bit of work for part B, but because it's a lot of repeated work from part A, you're maybe not getting as many marks. Okay, now C is proving the direction of the beam is perpendicular. Okay, so we need to prove that it's perpendicular. Now what I'm going to do here is I'm going to pause it, mark this. I'll mark this, pause it, clear this, and then do C and D together in that space. Give me a wee sec. Oh, in fact, sorry, I need to mark it first, don't I? Daft. Okay, so in part A, you get 1 mark for getting the vector, 1 mark for calculating the magnitude, and then the third mark for giving the correct distance. In part B, you are getting 1 mark for the magnitude all the way to there, and then 1 mark for calculating the speed. Okay, give me 2 seconds to clear the rest of that. Okay, so part C, prove the direction of the beam is perpendicular. So we know that perpendicular means that the dot product should be 0. So we want to know the direction of the beam. So we want to know the dot product of TC and BR is equal to 0. Now BR we already had. BR from part A is 2 minus 9/8. Now TC is C minus T, so 1441. Subtract T, which is 0, 0, 0, so nice and easy, 1441. Okay, now you want to show that it is perpendicular. We need the dot product to be 0 if it's perpendicular. If we're not getting the dot product to 0, the question's suggesting that it is, we know we made a mistake. So 2 times 14, add minus 9 times 4, add 8 times 1. That's 28 minus 36, add 8, which is 0. So BR dot TC is equal to 0. Therefore, BR is perpendicular to TC. Okay, and that's your part C done. Now the last bit is calculating the size of angle TCR. So T to C to R, you make the best angle in here. Okay, now similarly to the last question, okay, I'm just going to mark part C so I can clear it again. Part C, first mark is for getting the vector TC. Second mark is for calculating the dot product. And your third mark is for getting to 0 with an explanation. Okay, bear with me a wee sec. Okay, so looking at part D, calculating the size of this angle, we need the vectors that point away from that angle. So we need CT and we need CR. Okay, we know we're going to be working somewhere, and I'll just do it down here this time. So cos theta is equal to CT dot CR over the magnitude of CT times the magnitude of CR. Okay, so CT we know is T minus C. So 0, 0, 0, subtract 1441, which is negative 14, negative 4, negative 1. And then same with CR. Apart from it's 7 minus 4, 7.5. Subtract 1441. That's negative 7, negative 8, negative. No, rubbish, sorry. It is just 6.5. Apologies. I would go back and fix a mistake, but I'm 35 minutes into the video and I'm not doing it all again. Okay, so now we're needing the dot product. So the dot product is going to be minus 14 times minus 7, add minus 4 times minus 8, add minus 1 times 6.5. Okay, which works out to be 123.5. Okay, the magnitude of CT is equal to the square root of minus 14 squared, add minus 4 squared, add minus 1 squared, which is equal to root 213. This will be a calculator paper, obviously. And then magnitude of CR is minus 7 squared, add minus 8 squared, add 6.5 squared, which is root 155.25. Okay, which means we can go back to our cosine sum, and again, apologies for it being a bit squashed. 125 over root 213 multiplied by root 155.25, which means that theta is equal to the inverse cos of that big horrible looking fraction. Okay, which gives you 47.2 degrees. Okay, so again, let's look at the marking. Okay, 5 marks, very similar to before. Okay, 1 mark for getting it written as that formula, 1 mark for each vector, 1 mark for the dot product. In fact, there's 1 less mark here, so there's not going to be a mark for both vectors there. Okay, there'll be a mark for getting both vectors, a mark for getting the dot product, a mark for getting both magnitudes, and then the final mark for getting to the angle. Okay, let's go. So I think this is question 10. Question 10, just 3 to go. They're a lot shorter than the last 2, I wouldn't worry about that. Okay, the diagram shows representation of 2 vectors, A and B, inclined at an angle of 60 degrees. If those are your magnitudes, the value A dot A plus B. The first thing we need to know, the first thing we need to do is that when we're dealing with brackets with a dot product, we know that we can expand brackets like we always have in algebra. So that's the first thing we should be looking at there. Now, these 2 ways to get the dot product. One, the way we've been using up to this point with the components, where you multiply and add, or the other, where you have the 2 magnitudes and the angle in between. So magnitude of A times magnitude of A times cos theta 1 plus the magnitude of A times the magnitude of B times cos theta 2. So cos theta 1, if you've got magnitude of 2 vectors are the same, you know that's going to be 0, the angle between them. If you've got 2 A's, they point in exactly the same direction, so there is no space between them. So it's going to be 2 times cos theta, cos 0, which is just 1. So it's just going to be 2 times 2. And some of you may already know that and jump straight to magnitude of A squared. That's perfect. Okay, but you don't need to. We can figure that out. Cos 0 is just 1, so it's 2 times 2 times 1 in reality. Plus the magnitude of A, which is 2 times 3 cos 60. And from our exact values, we know that cos 60 is a half. So it's plus 2 times 3 times a half, which is just 4 add 3, which is 7. Okay, marking for that one. Nice wee question that people can often forget, but is worth remembering, obviously. Okay, 1 mark here for expanding your brackets, 1 mark for substituting correctly, and then the 3rd mark for evaluating it correctly. Okay, including the cos 60. This one here slightly more complicated. Okay, in part A, we're evaluating A dot A. Now, as we've seen in the last question, A dot A is always going to be the magnitude of A times the magnitude of A times cos of 0, which is always 1. So the magnitude of A is just 3, so 3 times 3 is 9. Okay, and I'm going to put that here. So 3 times 3, which is 9. Okay, B dot B, similar idea. Okay, is going to be the magnitude of B times the magnitude of B times cos 0, which is just 1. So it's 2 root 2. Sorry, it's 2 root 2 times 2 root 2, which is just going to be 2, 4, 8. And then lastly, A dot B, our last line part A, I should say, is going to be magnitude of A times magnitude of B cos the angle between them, which is 45. So magnitude of A is 3 times magnitude of B, which is 2 root 2, and cos 45 is 1 over root 2. Okay, and then simplifying that, your root 2's will cancel, and it will just be equal to 6. Okay, now part B is a bit trickier. Evaluate P dot P. Now P dot P really means 2A plus 3B. So this is going to be 2A plus 3B dot 2A plus 3B. Now we know that vectors dot with brackets just the same as they algebraically break out with brackets. So 2A dot 2A, that first multiplication, that first dotting, is going to be 4 lots of A dot A. Then we've got 2A dot 3B, so that's 6 lots of A dot B, plus another 6 lots of A dot B, plus the 9 lots of B dot B. Okay, now these things we already know. A dot A is 9, so that really means 4 times 9. So we've got 12 lots in total there of A dot B, so that's 12 lots of 6. And lastly, we've got 9 lots of B dot B, which is 9 lots of 8. And we're just simplifying it, or we're evaluating it, finding out what that really is. Okay, and it's 180. Now the last bit there, for part B, this is us evaluating P dot P, and hence write down our root, the magnitude of P, sorry. Now we know that related to the magnitude, P dot P is equal to root P times root P times cos the angle between them, which again, because it's the same vector, we know is 0. So this just means the magnitude of P squared times 1. So if we know that P dot P is 180, 180 is equal to the magnitude of P squared. So the magnitude of P is just going to be root 180. Okay, you could simplify that sub, you're not going to get any marks for it because it's an National 5 skill. Okay, marks here, you're going to get 1 mark for both of those ones, or one of these ones, depending on the marking scheme. The second mark is for calculating A dot B. For part B, you are going to get 1 mark just for swapping in the AB brackets. The second mark for multiplying out those brackets. The third mark for evaluating the dot product, and then the fourth mark for then turning that into the magnitude. Okay, and I believe this is the last question. Thanks for bearing with me. Best 45, 50 minutes of your life, no doubt. Okay, so the first thing is, again, we're dealing with brackets here. So it's A dot A plus B plus C, which really means A dot A plus A dot B plus A dot C. Okay, which really means, again, we don't know the components. It's going to be the magnitude of A times the magnitude of A times cos of the angle between them. Let's call it theta 1 here, plus the magnitude of A times the magnitude of B times cos theta 2, the angle between those two vectors, plus A G magnitudes times cos of theta 3. Okay, so 5 marks, lots of marks here. We're doing all right so far, nice and easy. Break the brackets, substitute in the formulas. So the magnitude of A, okay, it's an equilateral triangle, 2 units long. So the magnitude is going to be 2 the whole way around. So it's 2 times 2 times cos of 0, because again, they're the same vector, so the angle between them is 0. That's 2 times 2. Now the angle between A and B, because in an equilateral triangle, is going to be 60. So 2 times 2 times cos 60. Now the last one, you've got to do right on top of. Okay, because A at the minute, A and C do not leave the same angle. Okay, A points into that angle, C points away from that angle. So what we need to do is we need to move this vector A from where it is across to here. So that's exactly the same vector. Well, it's not exactly the same because it's a messy line, but move to the same place in the other side. So that is still the same line, it's just been extended. We've got A here. We know this angle here is 60, so this angle here has to be 120. So we're doing plus 2 times 2 times cos 120. Okay, so this cos 0 is 1, so that's just 2 times 2, which is 4. Add cos 60 is a half, so it's 2 times 2 times a half, so 2 times 2 is 4 times a half is 2. That cos 120, if we're doing our exact values for cos 120, we know that 120 is in the second quadrant. So cos 120 is going to be a negative version of cos, because in that second quadrant cos is negative. The related angle of 120 in that quadrant is 60, because it is 60 that we take away from 180 to get to 120. So cos 120 is negative a half. So this really means 2 times 2 times negative a half. So add negative 2. So your final answer there is A dot A plus B plus C is equal to 4. And finally, the marking for that. Okay, the first mark again, let's make sure we're picking that up for expanding the brackets. The second mark is for evaluating, or for substituting in correctly for A dot A. The third mark for A dot B, and the fourth mark for A dot C. And then the fifth mark for then evaluating your answer. Okay, so I appreciate you listening to that. I hope it's helped in some way, shape or form. If there's any other issues or even any other vector questions you want me to look at on this, just give me a shout either in the comments below, or Twitter, or just in school. Thank you very much for your time. Bye now.